have a bit of a explanation to start off with, just so we all understand what's going on in the world of decimals. I'm gonna be honest, you know that I have some feelings about certain numbers in maths. Decimals is another one that I just don't enjoy at all. Mixed numbers I don't like, decimals I don't like. I have many weird things that I don't like in maths as much as I love maths. So in all honesty, decimals does not feature massively from about grade 10 all the way up to matric. It's, I don't want to say we don't use decimals, but we don't even need to be able to like convert a decimal or anything like that. Like we find other ways of doing that, especially once we start learning more advanced algebra and so on. So it is important to understand how to do it, and it's important to understand why they convert the way they do. And that is what we're going to speak about today. Right, so I know that some of you are already putting answers in the chat, and that's cool, but there is something I want to explain, and there's a reason I'm starting with this example before we just jump in. All right, so I want you to forget about the division for a second, and I want us to have a look and see what happens when we multiply by multiples of 10. So for example, if I said, sorry, I don't know what happened there. If I say 3 times 10, we all know that that answer is 30. If I were then to go one multiple of 10 up and say 3 times 100, we know that that would be 300. And if I keep going up in my multiples of 10, so if I now times by 1,000, if I were to times by 10,000, hopefully what we're starting to see is that there is a pattern emerging with the number of zeros that then are present in my answer. Now, if you aren't seeing a pattern, don't stress, that's cool. We're about to chat about the pattern. But essentially what you're seeing is every time you, no, let me start that sentence again. If we times by 10, 10 has 1 0, and so I'm adding a 0 to my answer. If I'm timesing by 100, 100 has 2 zeros, I'm adding 2 zeros to my answer. And this pattern remains consistent all the way through as I go up my multiples of 10. Now, another way to look at this is in terms of a decimal. Now, any whole number that I have, so this 3, the decimal or the comma is always straight after that number. And so what I see is happening here, when I multiply by 10, my decimal has moved from just straight after the 3 to now be after the 0. It's moved 1 unit or 1 place to the right. I'm just going to use R for right. If we go and have a look at 100, because there were 2 zeros here, my decimal, my comma moved 1, 2 to the right. And so my pattern again keeps going. I times by 1,000, I move 1, 2, 3 to the right. I times by 10,000, 1, 2, 3, 4 to the right. And so what we're seeing is that when we multiply by multiples of 10, tedious, right? We are moving our commas however many zeros to the right. Okay, so this is something that we're now going to apply when we start talking about dividing. Now, the point of this lesson is so that you can convert fractions to decimals without a calculator. So, okay, guys, I have not even started the examples yet. So please stop stressing. I haven't even touched on 3 over 10 yet. I'm getting there. I'm trying to explain the concept of how we do this. So I have not said that 0,3 is wrong. It is in fact correct, but I haven't gotten there yet. So just hang tight. We're getting there. Right. We now need to apply the same concept with dividing. Now, division is the opposite operation of multiplication, which means that now instead of moving to the right, I'm going to go the opposite direction to the left. So if we now go and investigate this whole sort of pattern that we saw, we're doing the opposite. So if I say 3 divided by 10, I'm dividing by 1 multiple of 10, so I've only got 1 0, And so instead of moving one place to the right, I'm now going to take my decimal, which is sitting at the end of the 3, and I'm going to move it 1 to the left. And so my answer here is now 0,3. I've moved that one placeholder that the 0 represents to the left. And this will now apply because we've seen this pattern to any multiple of 10. So if I said 3 divided by 100, I've got 2 zeros. So that's telling me I must move my comma 1, 2 places to the left. And so I've got 0,03. If I were to say 3 divided by 1,000, I've got 3 zeros in my value. And so I need to move my comma 1, 2, 3 to the left. So I've got 0,003. And so again, we see this pattern that we have. Now, what I want you to take away from this is the fact that when you are trying to convert a fraction to a decimal, if we can make the denominator a multiple of 10, so 10, 100, 1,000, 10,000, we can then just apply this pattern to whatever it is that we're working with. And so, yes, in the first example, we've technically already done it, but in this first example, we have a situation where we are saying 3 divided by 10, because I'm dividing by just one multiple of 10, so a number with 1 0, I need to take my decimal and I need to move it 1 unit to the left. And so my answer is exactly as you said, 0,3. Now, yes, we did it over here, but now we understand, hopefully, if we were listening, why I can say 0,3. Now, importantly, please don't use a dot. A dot in South African maths means times. Please don't use a semicolon. That is when we list numbers. Your decimal is represented by a comma. That's it. Right, so I'm going to wait here in case you want to take a screenshot. You might want to give me 2 seconds so that I can put a little note here that says when we divide by multiples of 10, we move to the left. Right, there you go. So if you want to take a screenshot of all of those notes, it's now there for you. And then we're going to have a look at some more examples. Alrighty, so let's have a look at question B to start off with. So question B, I'm now dividing by 100, which means I'm dividing by a multiple of 10 with 2 zeros. So 27 divided by 100. Now, guys, you don't have to write it with the division sign. You can if it helps you. And the reason I like to write it out with the division sign is because I can see that I've got 2 zeros. So I can see that my comma, which is now at the end of the 27, must move 1, 2 units left. And so I know then that I've got 0,27 as my decimal. I took my comma or my decimal point and I moved it 2 units to the left because the 2 zeros in my 100 told me to move it 2 units to the left. So what I want you guys to do is try question C for me. I'll leave question D there in case you want, but I want you to try C. Grade 8s, I need you to focus and I need you to do what I've asked. Please, so in the chat, the only things I want to see right now are answers to question C. Okay, I've asked you to do question C. I have done question B with you. So question C, please. Remember, I only want hands when I say I want hands. Just giving everyone a chance to have a go. and to try and do this answer, or to try and do this question rather. Righty, so if anyone would like to raise their hand, now is the time to do it, to explain to me how they did this. Didn't they?
Ma'am, I just said the answer is 0,007.
Perfect. So guys, we're saying 7 divided by 1,000. Now I haven't left myself much space here. So 7, if I just take that whole number, has a decimal at the end. I need to move it 1, 2, 3 units to the left. Now every little movement I make, there's a 0 that falls in front of that 7. So exactly as Didintle said, our answer here is 0,007. Now you can always check yourself on a calculator if you want to. If I type in, I don't think that's going to work. Let me just type in 27 over 100. Your calculator automatically, let's do this. Your calculator automatically gives you a fraction answer. If you go to the button on your calculator that says SD and you push it, so that SD button, it will convert your answer to a decimal. So for question B, where we had 27 over 100, if I type that in, I can see that my correct answer is 0,27. So I can always double check with a calculator. Now, obviously you need to be able to do this by hand. That's the point of the lesson, but you can always check your answers using a calculator. All right, so I'm gonna just leave that there in case you want to take a screenshot. And then if anyone has any questions, you are welcome to raise your hand at this point and I will answer questions before we move on to the next examples. So if you have questions, raise your hand. No questions, guys? Okay, Tolakele?
Ma'am, I wanted to ask, ma'am, that I see that for question example 1A, it says that 3 divided by 10 is 0,3, and the number of zeros there goes with the 10. And then also by B, no, C. Yes, C, I see that we said 7 divided by 1,000, and then the number of zeros are 3 because there's 3 zeros in 1,000. Does it actually go that way, or does it sometimes change?
No, it actually goes that way. Well, actually, no, let me take that back. It only goes that way if we are working with one number. So you'll see that in question B, that pattern doesn't exist because my numerator had 2 numbers. The number of zeros tells me how many times I need to jump the decimal. So if I've only got, so like in question A, I only had 1 number in my numerator. It was just a 3. It wasn't like 34 or anything. Because it was 1 number, then that pattern will exist. It will be 1 0. In question C, I only had 1 number. So the pattern exists. I've got 3 zeros. But it doesn't always happen. So, user 1, I know you're not user 1. Just remind me of your name.
Yes, ma'am. My name is Susanda.
Oh, excuse me. I'm so sorry. Okay, Susanda, tell me, what is your question?
No, ma'am, I don't really have a question, ma'am. Can I just see the top of the 3 divided by 10 and the, because I want to see so I can understand it more.
Okay, let me do this. There we go. Is that better?
Thank you, ma'am.
Alrighty, guys. So they are all 3 examples, just in case you didn't get a screenshot of A. I'm gonna wait like 10 seconds and then we're gonna have a look at some more examples. Okay, so guys, these were nice and easy because our denominators were already a multiple of 0. But obviously, we're not always going to be nice, and it might happen that our denominators are not multiples of 10. So we need to be able to deal with that. And that's what we're going to have a look at now in our second example. Woo, a little bit excessive. So the concept we now need to apply when our denominator is not a multiple of 10 is we need to remember that we have what we call equivalent fractions. So if you think way back to, I'm pretty sure it was our very first lesson on fractions. For those of you that are new, if you go and watch the videos, you will hear me talk about equivalent fractions. This is now the concept we want to apply here. Now remember, equivalent fractions are fractions that look different but represent the same portion of a whole. So a half has an equivalent fraction of 2 over 4, has an equivalent fraction of 5 over 10, has an equivalent fraction of 10 over 20. And there's like an infinite number that I can use. But essentially, if I simplify all of these fractions, I get a half. And so what that's saying is that I can make a fraction still represent the same amount, but with a different set of numbers. Okay, so what I want to do here is essentially make an equivalent fraction. Now, as we saw in the first example, the goal is to try and get our denominators to be a multiple of 10. So either 10, 100, 1,000, etc., etc. Now, don't make your denominator big unnecessarily. If you can make it 10, there's no need to make it 1,000. So looking at this denominator of 5, I can definitely make 5 a denominator of 10 because I know that if I times 5 by 2, I get 10. And that therefore means that I will do the same thing on the top. Remember, what you do to the bottom, you do to the top. And if I times 3 by 2, I get 6. And so what that means is I now have a situation of 6 divided by 10. And because we had the discussion up here about how we deal with division by multiples of 10, this becomes easy to do. I move my decimal 1 unit to the left. And so I've got 0,6, as a lot of people were saying there on the chat. So what you want to do, sorry, my laptop's just getting a bit hot here. So what we want to do is we want to make our denominator a multiple of 10. If we can do that, it means we can apply this pattern or this rule that we discovered. So what I want you guys to do, whoopsie, sorry. So I want you guys to try question B for me. And I'm going to leave question A there just in case you want to see sort of a reminder of what we were doing. But have a go of question B for me. So remember, we want to try and make that denominator a multiple of 10. I want answers typed in on the chat. And only when I say hands will I accept hands.
Let's go, guys. My network is bad. I'm not sure if Teacher Sam's network is also bad. But we are doing B, right? B, my people. Let's go. You see the nice explanation for A? To just do exactly the same to achieve B, my people. We can do this. I'm on load shedding. I'm not even sure if anyone can hear me.
We can hear you.
Nice.
Okay, guys, seeing some awesome answers. Would anyone like to raise their hand to explain how they did what they did? So I want an actual explanation here, please. Right. Kopano, do you want to help me out here?
Afternoon, ma'am.
Hi.
So you would say first you'd have to convert the 25 to 100. So then you'd say
Okay,
25
perfect.
times 4,
Good.
and then that'll be 100. And what you do to the bottom, you do to the top. So then it'll be 17 times 4. And then 17 times 4 is 68. So then the decimal will be 0,68.
Excellent. So guys, what we wanted to do there is we wanted to convert our denominator to 100. I can't convert it to 10 because 25 is already bigger than 10. So I'm making life hard if I do that. So I go the next multiple up, 100. Yes, I can make 25 100. And so I can go from there. Now remember, your decimal is here at the end of the 8. We need to move it 2 units to the left. So 1, 2, which is why we've got 0,68 as our answer. Now again, grade 8, you can use your calculator to double check yourself. So if I type on my calculator 17 over 25, my calculator automatically gives me the fraction version of my answer. Can't see my face anymore. This could be a bit of a problem. If I now push that SD button, so I push it, it will give me 0,68. And so I've done this question correctly because I've got the same decimal. So again, use your calculator to check yourself, but show all of your working out. Mvelo, we had this discussion in the last class. 50 doesn't um, 50 doesn't work as well because of the fact that you're not, you aren't using a multiple of 10. So what you would be doing is you would be timesing that by 2 only. And so your decimal then is only English. So that means 50 is 5 times 10, which means your comma would move 1 unit to the left. But because it's not a multiple of 10, that rule doesn't actually apply. And so what that means is that we would then have to go a step further and still convert it to 100. So 50 does create more complications if we try and do it like that. I'm not saying you can't do it like that. I'm just saying it does become a little bit harder to do it. So if you just stick to getting your denominator to be a multiple of 10, it makes life easier. Right, so again, not that you can't do it, it is a little bit more complicated. All right, at this point, if anyone has any questions, you can raise your hand. Please remember that we wait until I say raise your hand for questions or for answers, otherwise it becomes a little bit overwhelming.
Let's go, my people. Did we get 100%? Did we get B correct? Let's see with the emojis show that you actually got it correct. There we go. Let's go. Did Dinka and Ritabila have those hands to ask questions?
I think
Let's
so.
go. Okay, then we can take them now.
Okay, Ritabila, question?
Good afternoon, ma'am.
Hi.
I just wanna ask why did you multiply 25 by 4?
Because 25 times 4 is 100. And remember, we want our denominator to be a multiple of 10. So we want it to be 10, 100, 1,000, etc., etc. So in order for me to make 25 100, I times it by 4. Does that make sense? Okay, guys, just remember when you do raise your hands, when you're done with your question, just remember to lower your hand and mute yourself. Otherwise, it creates chaos. I'm going to sneeze. Oh, I'm so sorry.
No, bless you.
Okay, Didn't question. Tandawetu, I do see your question on the chat. I'll get you in a second. Didn't
Ma'am, when the denominator is like 1 digit, ma'am, is it then when you have to like times a number to get 10, and when it's like 2 digits, you have to get 100 times the number to get 100?
Yeah, it generally, 90% of the time, yes.
Oh, okay.
It depends what the number is, but most of the time that is like the general sort of rule. Guys, I'm going to give you another example. Don't worry, I'm just trying to answer everyone's question so we all are happy. Tukolo?
Evening, ma'am.
Hi.
Ma'am, may I please ask? I came here late, so I didn't literally hear everything. So it's supposed to always be 100? It can't be 10. So if it's
It can be 10.
If it's under,
So
like the number is under 10, like 2, 3, 4, 5, is it supposed to be the denominator must be multiplied by 10 to 10?
generally, yeah.
But ma'am, what if the thingy is 6? The denominator is 6.
So that's what I was saying earlier. It doesn't always apply, but it generally does. So 6, you would have to, yeah, 6 would be a hard one. 6, you'd have to find some multiple of 10 that 6 can divide into. So let's see, not 1,000, not 10,000, not 100,000. It's getting gross. So we would try not to give you something really mean like that, but you might, yeah, you then would have to keep going until you can find a multiple of 10, but we will try not to make it so that the denominator is like 10 million, because then that's just silly.
Yes, ma'am. Thank you, ma'am.
So, all right, Calvin.
Okay, ma'am.
Hi.
I just wanted to ask if does the number always have to be over? Okay, let's say you can times 25 by 2, which will give you 50, because you said that to be like a multiple of 10. So can it just be like 50, and then 17 can be like 34, or does it have
A
to be over?
multiple of 10 is 10, 100, 1,000, 10,000, etc., etc. So we want it to be that.
Oh, okay, thank you, ma'am.
Right, those people with their hands up, I really hope that you're listening to everyone's questions. I'm going to take one more hand because we need to move on. If I don't pick your hand, please put your answer in the chat or send myself or Yolanda a message and we will help you. All right, Nompilo?
Hello, ma'am.
Hi.
Hello, ma'am. Ma'am, I would like to ask that if the numerator, is it a must to multiply the numerator and the denominator with the same number?
Yes, we have to, because remember what we want to do is we want to create an equivalent fraction. If we don't, what it means is that we're changing the meaning of the fraction, which we don't want to do. We want it's meaning the same thing, we just want it to be in a more user-friendly format. So we have to times top and bottom by the same thing.
But ma'am, but then if the numerator is bigger than the denominator and you have times the denominator with a number to get 100, and then when you times the numerator, the number is bigger than the 100, can that happen?
Okay, so this is a really good point that you brought up. Whoops. Let's have a look and see what happens with that. All right, so guys, I'm hoping you've all taken screenshots here. Those of you wanting another example, I'm going to use Nompilo's example here because it's sort of where I was going anyways, and then we'll have a look at a couple more. Right, so if we have a situation, let's say, for example, we've got 7/5, and I'm asking you to convert that to a decimal. We still do the same thing. So what I want to do is I want to make this denominator a multiple of 10, and we know that if we times 5 by 2, we're going to get 10. And so I'm going to do the same thing with my numerator. I'm going to times 7 by 2, and that's going to give me 14/10. Now, all that happens here is, like Nompilo said, if my numerator is bigger, what we need to remember is that this represents a mixed number, essentially. This would be 1 and 2/5. I'm talking about more than a whole here. So that means my decimal needs to sort of represent that as well. So what I have, according to my new fraction, is 14 divided by 10. And we know that when we're dividing by 10, we take our comma and we move it 1 unit to the left. And so what I now get is 1,4. Now, if you have a look on your calculator, 7 divided by 5, there it is. There's your improper fraction. If I push SD, it gives me 1,4. 7/5, because it's an improper fraction, it's more than a whole. And so my decimal will have a number in front of the comma and then the remainder. So we still do the same thing, even if my numerator is bigger than my denominator. Pilo, I hope that answers your question. Right, guys. So hopefully you've now seen what happens when we've got a situation where our numerator is bigger than our denominator. The method doesn't change. Our answer looks a little bit different. We no longer have a 0 in the front, but our method stays exactly the same. Right, so take a screenshot and then we're going to have a look at another example. I don't think we're going to have time for a brain break tonight, but we'll see how we go. Right. So I feel like I might have been mean here, but let's see what happens. 13/40. Oh. We want to make this a multiple of 10. So can we make this a multiple of 10? That's the first question. Give it a try. You can make it a multiple of 10, but I will give you a hint in that we can't make it 100. It needs to be a multiple bigger than 100. That's my only hint I'm going to give you. I don't want you to use a calculator, guys. The whole point of this is that you can do this without a calculator. So please try this without a calculator and see what you get as your decimal. These answers are coming through way too fast for me to believe that you're doing this without a calculator, but okay. I will believe you. Okay, so all of these people, does anyone want to raise their hand and explain to me how you got 0,325? Excuse me. Okay, Lawrence, do you want to explain for us?
Hello, ma'am.
Hi.
And so how I got 0,325 is I said 13 times 2.
Okay.
Then I said 40 times 2, which gave me 80. And then, so I wrote it obviously in a fraction. And then after dividing it all together, the 26 divided by 80, I got 0,325.
Okay, but how did you get that? Like, how do you know that it's 0,325?
Ma'am?
Because this denominator isn't a multiple of 10. That's a multiple of 8.
Oh, okay.
Okay, so your answer isn't wrong. It is 0,325, but excuse me, we can't get to that from 26/80.
Okay, ma'am.
Okay, so, okay, good try. Well done. Woody, do you want to try for us?
Hi, ma'am.
Hi.
So I said 13 times 25, which gave me 325. Then I said 40 times 25, which gave me 1,000. So I said 225 divided by 1,000, which gave me 0,325.
Perfect. So guys, this is what we need to be doing. 40 times 25 exactly is 1,000. That is now a multiple of 10. I do the same thing in my numerator. So 13 times 25. 13 times 25 is 325. And now that my denominator is a multiple of 1,000, I can apply my rule. So 325 divided by 1,000, I've got 3 zeros here. So that means I need to take my comma or my decimal and move it 1, 2, 3 to the left. And so I've got 0,325. So again, guys, if you're doing this without a calculator, which I'm really hoping you are, what you need to do is you need to get it to a denominator of a multiple of 10. That is the only way we're able to apply the rule that we know. If you're doing any other denominator, there's no rule for that. you're making it more complicated for yourself. And so multiples of 10 in our denominator is what we want. Alrighty, so take your screenshots. If anyone has any questions, now is the time to raise your hand and ask. Any questions, guys? Didn't Claire?
Ma'am, when you said a multiple of 25, ma'am, what did you mean by that, ma'am?
A multiple of 10.
Of 10, yes, ma'am, of 10. Doesn't
Okay.
it mean 10, 20?
So, wait there. Sorry, it's all just gone haywire. Right, so guys, when we're talking about, maybe multiples isn't the right word, but like each time I times 10 by another 10, I suppose maybe powers is better. So 10 times 1 is 10. 10 times 10 is 100. 10 times 10 times 10 is 1,000. So each, yeah, okay, no, that's a very fair point. My words clearly are not working today very well. But essentially, each time I multiply by another 10, I'm adding on zeros. Thanks, didn't Claire? You're the only one who's picking up that I'm talking nonsense. So there was another one, Fanalisa Bunga. Yes, you need to multiply at the end of the day. It's very rare that we ever divide. Wanda Wonke? Wanda Wonke, are you there?
Yes, ma'am.
Yes, what's your question?
Ma'am, I want to ask a question about the quiz. So the quiz, is it like about the work that we've done last week and this week also?
Essentially, yes, because it's the end of course quiz.
Okay, ma'am. Thank you.
Yep. Sasanda?
Yes, ma'am. I wanted to ask if there was another method of doing this, but you got the answer right. Do you still have to do with this method?
I mean, you don't have to. This is definitely the easiest way. Like, there'll definitely be other ways to do it. And they just are a little bit more complicated. So this isn't the only way. This is just like, I hesitate to say this, but a lot of textbooks use this method.
Yes, ma'am. Thank you.
Cool. Tolakele, I'm trying to get to percentages. That is actually my next example. So Tokolo, last question.
Ma'am,
Yes.
is there like another method to do this thing? How do you get the number that you're supposed to multiply with? For example, the example that you used here, you said 40 times 25. How are you supposed to get like the 25?
Okay, so it is a bit of trial and error. Basically, what I did on my calculator is I knew that I was trying to find a multiple of 10 that I could divide 40 into. So there's different ways you can do it. You can say 100 divided by 40. It gives you a fraction, so I don't like that. So if I go and say 1,000 divided, let's try that again. If I say 1,000 divided by 40, I get 25. And because it's a whole number, I know that 25 times 40 gives me 1,000. So it's a bit of trial and error to start off with.
Okay, thank you, ma'am.
Obviously, guys, if you know your times tables really, really well, like your 25 times tables all the way up to 40, you'll probably know this, but I'm impressed if you know that. All right, so guys, let's just have a quick chat about percentages, because percentages do go hand in hand with fractions and decimals. Basically, what I want to point out to you is the fact that a percentage, whilst it doesn't look like a fraction, is automatically a fraction over 100, right? So if you have 65%, remember percentage essentially means parts of 100. I can't spell. That is what a percentage is. It's how many parts do we have out of 100. And so 65% is 65 parts out of 100. And now because we understand what to do when we have got a denominator of 100, because we understand that all we need to do is take these two zeros and move my comma 2 places, it's very easy to convert a decimal, to convert a percentage to a decimal. And so what we need to realize is that percentages is just something over 100, right? So if we sort of apply this to maybe like a more real world scenario, often percentages come up in concepts like markups, like price markups in shops and stores and businesses and so on. And a markup is often more than 100%. So let's say we've got a markup of 225%. I want you guys to try and write that as a decimal for me. So take what I've just told you about what a percentage is and write it as a decimal. Okay, guys, when I say no calculator, I mean you can't just type it into your calculator and get an answer. You have to show you're working out. As I've continuously said throughout this lesson, use your calculator to check yourself and use your calculator to help you, but show all of your working out. Right, so 225%, I want you to try and convert that to a decimal for me. I've seen one answer so far come through in the chat. Keep them coming. And what I want you to think about is this is more than 100%. So it's representing more than a whole. And so your decimal should reflect that. And that was already a question that we had. So this will show how well everyone was listening to the answer to that question when we have an improper fraction. Again, guys, remember your decimal is a comma. It is not a dot. It is not a semicolon. A dot in maths actually means multiplication. And so we don't want to get confused between comma and multiplication. So it has to be a comma. A semicolon is what we use when we do a list. So we're not listing anything here. We're giving an actual value. So it's a comma. Right. So 225 divided by 100, that is what that percentage is telling me. We know that we take the number of zeros, and that indicates to us how many times I should move my decimal. So my decimal, my comma is currently after the 5. I move it once, twice, because there's 2 zeros. And so this is 2,25. Right, again, if you want to check on your calculator, 225 divided by 100, it gives you a nice simplified fraction. You don't need to stress about that right now, but if you convert it, there it is, 2,25. So you can double check yourself. Grade 8, we seem to have forgotten the hands rule, which is a little bit disappointing because you were doing quite well for a little bit. Okay, now I'm happy to give you another example. I assume you mean of the percentages, which I will give you another example of before you guys get the quiz link. What I'm going to do is I'm just going to make that a touch smaller so that we can fit it all in. So let's mix it up a bit. Let's say negative 175%. So I want that as a decimal, please. So negative 175%. I want you to write that as a decimal for me. Remember, your decimal is a comma, not a dot, not a semicolon. I did say we probably weren't going to be able to take a brain break, unfortunately. Nice, guys. So negative 175 divided by positive 100. We know that a negative divided by a positive is a negative. We know that that division by 100 is telling me to move my comma 1, 2. So it's 1 comma. and it's negative. Right, just because as I was doing this, I thought of something. If I gave you, for example, 17.5%, this is essentially 17.5 divided by 100. And so we use the same method, but what we need to be careful of is now my decimals are already there at 17.5. So when I divide this by 100, I take where the decimal currently is and I move it 1, 2. And so this would be 0,175. So if a number already has a decimal in it, we don't just move the decimal to the end. We use it where it currently is, and we can then convert to a decimal. So in this case, because there was a decimal at 17.5, that is the comma I then use to move accordingly. Right, so that was just something I wanted to point out.